All right, welcome to the worksheet video for 2.1. Here you go. Put your name on it, put date, block, and we're good to go. All right, I'm gonna work through all of these with you. Try your best to fill in the blanks for the definitions we have so far. So all definitions are called biconditionals, by definition. Definition is biconditional. And because it's the biconditional, you can use the phrase if and only if. And it means that the statement and the converse are true. So the if and the then can be switched and there's no contradiction. So that's an angle, or that's a definition. So acute angle, we already know these. These are things that we already know. So what I want you to do is I want you to pause, try to fill in these as best you can. Okay, and we're back. Here we go. Acute angle. An angle is acute if and only if the measure is between 0 and 90. Obtuse. The angle is between 90 and 180. A right angle. The angle is exactly 90 and a straight angle is exactly 180. All right? Nothing new. Nothing new. Those are just angles. Congruent. Congruent. Two segments or angles are congruent if they have the same measure. Adjacent. Adjacent if they have a common vertex and side. So adjacent angles have a common vertex and a common side. Angle bisector. If it divides an angle into two congruent angles. See, now I can use this word since I defined it up here. I can now use that word to make new words. Complementary angles, if they sum to 90. Supplementary angles, if they sum to 180. Collinear, points that lie on. Lie on the same plane. A midpoint, it divides a segment into two congruent segments. Segment bisector goes through a midpoint. And once again, you can see we're using this word to make a new word. Now that we know what midpoint is, I can use it. Opposite rays. They have a common endpoint and form a straight angle. Sorry, I was running out of room there. Form a straight angle. That's straight. Perpendicular lines. They form right angles. Linear pair. This is the abbreviation for if and only if. If and only if they have a common vertex and non-common sides are opposite rays. Let's call them opposite rays. And then lastly, vertical angles. Angles are vertical if and only if they are formed by two intersecting lines and are not adjacent. Two intersecting lines. These two are adjacent. These are not vertical angles. These two are non-adjacent. Those are vertical angles. Okay, next. Number 2. Say always, sometimes, never. So obviously, pause the video. Try to fill it in yourself. Let's see what we come up with. If two angles are a linear pair, then they are, well, go to the definition. Angles are a linear pair if and only if they common vertex and non-common sides are opposite rays. Common vertex and a non-common side means that if you have a common side, that is always true. Linear pairs will always be next to each other and adjacent. The sum of two acute angles is an acute angle. Well, depends. Like a 20 degree plus a 30 degree makes a 50 degree angle. That's acute. A 20 degree plus an 80 degree makes 100 degrees. That's not acute. So the answer is sometimes. Okay, next. Vertical angles are never adjacent. In fact, that's part of the definition. They are not adjacent. Vertical angles are not adjacent. Two lines that do not intersect are parallel. Two lines that do not intersect. This is a tricky one. I got to bring in a third dimension here. Okay, this is a cube looking thing. These lines do not intersect. And they are parallel. That line and this line do not intersect, but they are not parallel. That is actually sometimes. Two lines parallel to the same plane intersect. Okay. That is sometimes. Think about, look up at the ceiling. Okay. There's lines in the ceiling. All of those lines in the ceiling are parallel to the floor. Some of the lines in the ceiling intersect. Some of the lines in the ceiling are parallel. So that's why the answer is sometimes. Two lines parallel to a third line are parallel. Let's check this one out. So if the blue line is parallel to the red line, and the red line is parallel to the orange line, then that would also imply that the blue line is parallel to the orange line. So that is always. Just throwing that out there. Okay, next. Now on to some real, looks like actual problems here. Not going to do all of them. Use diagram to determine whether you can assume the statement. Can you assume that planes W and X intersect at line KL? Here's plane W, here's plane X. Here's line KL. I would say, yeah, go ahead and make that assumption. You can assume that. It's more of a conclusion than an assumption, though. Next, can you make the conclusion that K, L, M, and N are coplanar? So K, L, M, and N. It looks like all four of these points are in plane X. So I'm going to go ahead and say, yeah. All right. Can you assume or conclude that Q, J, and M, Q, J, and M are collinear? I would say no. These are definitely not on the same line. So I would say no. Can we assume that these lines intersect? Line MN and line RP? No, they're kind of, it looks like they intersect maybe a diagram, but they're actually on top of each other. So this would be a no. See what you can get for the rest. Oh, here's a big one. Can you assume that PLK is a right angle? Is this a right angle right here? That angle? Does it have a right angle symbol? No, it does not. Can we assume that it's a right angle? No, we cannot. All right, do the rest. Next, select the statement about the diagram you cannot conclude. Oh, select all statements you cannot conclude. Can we conclude that A, B, C are coplanar? So here's A, B, and C. Yeah, they're all in plane T. So that one's good. Can we assume or conclude that T intersects plane S in line BC? Here's the line. I would say yes, that is the line of the planes intersecting. So that one's good. Can you assume or conclude that line AB intersects line CD? Nope, those do not intersect. They're next to each other, but they don't intersect. What other ones? Can you come up with more? There should be another one or maybe two. Next, describe and correct the error. The statement says M is the midpoint of AC and BD. No, if M was a midpoint, then this would have 2 marks and this would have 2 marks. So M is not a midpoint of this line, and M is not a midpoint. So here's how we can correct it. Put 2 marks on that one. So now M is a midpoint, and we'll put 3 marks on this one. And now M is a midpoint of that, and now M is a midpoint of that. Okay, next, can we conclude that they intersect at a 90-degree angle? And the answer is no, because there's no right angle symbol. But we can correct that. If we put the right angle symbol, now we can make the conclusion that they are perpendicular. 45. Now this is deductive reasoning at its purest. We have facts. Yellowstone is a national park in Wyoming. You and your friend went camping at Yellowstone National Park. When you go camping, you go canoeing. If you go on a hike, your friend goes with you. You go on a hike. There's a 3 mile long. So these are all facts. Now they might not be in the right order, but can you use these facts to determine if this is true? Okay, so is it true that you went camping in Wyoming? Let's see. You and your friend went camping at Yellowstone. And Yellowstone is in Wyoming. So I would say we can make that conclusion. You went camping, and you went camping in Yellowstone, and Yellowstone is in Wyoming. So that's kind of our thought process. You went camping happened in Wyoming. Sorry, camping happened in Yellowstone is in Wyoming. So we're set. Can you conclude that your friend went canoeing? Let's see, your friend went camping. When you go camping, you go canoeing. If you go on a hike, your friend goes with you, but it doesn't say when you go camping, your friend goes with you. So I don't think we can conclude that. I don't think we can use this information to say that your friend went canoeing. Next, your friend went on a hike. Okay. You and your friend went camping. Okay, so you and your friend went camping. When you go camping, you go canoeing. If you go on a hike, your friend goes with you. If you go on a hike, there's a 3 mile trail at your campsite. Oh, it looks like this. What's up?
Do you have any of those packets?
Yeah.
Am I interrupting you? Sorry.
Yeah, I'm in a video. Right there. It's okay. There's a packet right there.
My bad.
No,
Take two, is that good? Or
yeah, you can take 2.
All right, thank you.
Okay. All right, let's see here. Your friend went on a hike. Can we make a conclusion? Camping. You go camping. You go on a hike. If you go on a hike, your friend goes with you. So I would say we can go ahead and conclude that. If you go on a hike, your friend goes with you. Your friend went on a hike. Sure. Next, you and your friend went on a hike on a 3 mile long trail. We established that you go on a hike. We established that if you go on a hike, your friend goes with you. Did they say that you guys went on a hike on this 3 mile long trail? I don't think we can assume that. You can't assume that you went on that 3 mile. You might have went on a hike on a 6 mile long trail, but not that 3 mile long trail. So we cannot make that assumption that we went on that particular trail. And that is the homework. So welcome to deductive reasoning.